Okay, to show you kind of the simple idea of this, if I take 2/3 plus 1/4, let's see, what is that? That's 8/12 plus 3/12, so that's 11/12, right? What partial fraction decomposition does is we start with 11/12, and we want to know what two fractions were used to add together to get the 11/12 in the first place. So that's what partial fraction decomposition does. So what we do is we know that 12 can be broken down into a possibility of 3, 2, 4, and 6, and we put variables on top of those, and we do a whole bunch of math to figure out that it was 2/3 and 1/4. That's the gist of it. We're going to go through it. I'm going to show you how to do it all. I'm just showing you with regular numbers that's the idea behind it. The reason has to do with calculus. This is one of those things that I'm teaching you how to do without being able to give you the reason behind it yet. But the reason why we're doing this is because this involves solving systems of equations. Okay. All right, so the way we do this, first thing you're going to do is you're going to factor this. So if I factor this, that factors into x minus 3, x plus 2. You okay with that? So I write a fraction over here with each of those on the denominator. And I'm going to put a variable on top of those. Now what we usually use for a variable is just uppercase alphabet. We start with A and go across with however many we need. Now, we're going to solve that. Now, to solve that, what we do is we start by getting rid of the fraction. So to get rid of the fraction, I multiply both sides by the denominator. So what I'm doing is I'm going to take both sides times x minus 3, x plus 2. So I have to take each thing times that. Okay, you with me so far? Because these are the same steps on every single problem. So I multiplied everything by this denominator, but just in the factored form. everything. Yep. Yep. Okay, and what's going to happen is over here, it totally cancels out. So I get x plus 7. Over here, the x minus 3 cancels out. So I get x plus 2 times a. On this one, the x plus 2 cancels out. So I get x minus 3 times b. Cross multiplying, that's not cross multiplying. Yeah, but that's not cross multiplying. I know what you're saying, yes, but mathematically that's not correct. No, it doesn't. What happens when we have 4 things on there? Yeah, okay, I understand what you're saying. When we get to later examples, it doesn't work that way. Okay, what I want to do is on the right-hand side, I want to group like terms based on the x's. So if I knew what a and b were, let's say a was 2 and b was 5. I would have 7x, right? Because I take the a plus the b. So I'm just writing that out. So all I'm doing is I'm grouping like terms. Okay, now, here's everyone with me so far, because here's the part that usually, for some reason, this is the part that some people, it blows their minds. Okay, we said it's equal, right? So the left-hand side has to be equal to the right-hand side. So whatever's in front of the x on the left-hand side has to be equal to whatever's in front of the x on the right-hand side. Whatever the constant is on the left-hand side has to be equal to the constant term on the right-hand side.
If it was 2x.
So whatever's in front of the x here, which is just a 1, has to be equal to whatever's in front of the x here. So a plus b has to be equal to 1. Whatever the constant term is over here, so whatever comes next over here, has to be whatever's equal to whatever comes next over here. So I set up two equations. So I have a system of equations. Now that I have a system of equations, I can solve for a and b. Why did I take that times 3? Now, you're like, okay, great. A is 2, B is -1. I'm done, right? No. Because what we were looking for is the partial fraction decomposition. We found A and B, but our answer is 2 over x minus 3 minus 1 over x plus 2. So those were the fractions I had to add or subtract in order to get this. It's subtract. I just took the negative from the -1 and put it out in front. It could be plus, and you could put the negative sign back up there. That's fine. All right, you okay with that? Any questions? Because that was the easy one.
What?
Yeah, I have 3 more examples. You know they always get harder. Oh yeah, all the rest of the examples, I left a full page for each one of them. You remember have you ever had one of those math teachers to say, yeah, whenever you get up into higher level math, you have these problems that take like a full sheet of paper? Smart people. That's why, you never had that issue. He didn't get it. Yeah, people who did not have smartphones or video games or Netflix. Okay, so I factored it and I got that. Okay, on this one, you have to do 3 fractions. Whenever you have something that's squared, or any power, you have to do each iteration of that power. So if I had something that was to the 4th power, like if I had x plus 1 to the 4th power, I would do x plus 1 squared, x plus 1 cubed, x plus 1 to the 4th. No, you guys won't have anything higher than squared. I'm letting you know so you kind of get the idea of what you would have to do. Then it makes the squared makes a little bit more sense, hopefully. But whatever power you have out here, you have to do all iterations of it.
So if you didn't have an x, its edge, you wouldn't have to do that.
This x, yeah, I wouldn't have to do that. Yeah, the x is there because it's one of the factors, not because of the x plus 1.
So where did the x plus 1 come from?
I factored this. Whenever I factor that, I get x plus 1 twice. So I have 3 factors, but this one happens twice, so I need to write it as a square.
What about that square though? Like you did on B.
Yeah, anytime you have a power, so if I had something that, let's say that I had this, I would write it down like this: x plus 1 squared x plus 1 cubed, x plus 1 to the fourth. Anytime you have something to power, you have to write down all the lower powers of it. So if you have something that happens more than once, you have to write it as a power. So that doesn't have anything to do with our problem. Okay, so now we need to solve this. Okay, I'm going to take a little bit of a shortcut just to save some space. Now, what would this one be multiplied by? X plus 1 squared, right? Wherever I multiply both sides by the denominator, what would cancel out with what's underneath the A? The X, right? With the B, what would cancel out? One of the X plus 1. So all that would be left would be an X and one of the X plus 1s. With the C, what would cancel out? The X plus 1, both of them. So all that would be left would be the X. So I just left out the step where I wrote all the entire line of multiplication to save space. So I multiply everything out and I would get that. Okay, I need to combine like terms. Okay, so for x squareds, I have a and b. For x's, I have a little bit of everything. For a constant, oh, that's nice. All I have for a constant is a. So now I take this and I set each thing equal to its corresponding thing on the other side.
Where did you get the A2X?
Oh, okay, whenever I multiply this back out, it's going to be equal to this, right?
Yeah. Oh.
So then I took a times each one of these things.
Okay, I started to freak out. And then for the B1, do you multiply the X by the X plus 1?
Yeah, so that'd be x squared plus x, and then I put a b with each one of them.
No.
Okay, so a equals 6. So since a equals 6, what does that mean b equals? And since b equals -1, that would be 2 times 6 minus 1 plus c equals 20. So c equals 9. Oh, I was just planning on 9, maybe 8. Yeah.
What?
Can we do like 5?
Oh my God, guys, 1 or 2. From here, if A is 6, from here, A is 6, right? Okay, you ready for the next issue?
I'm trying to like make it make sense in my head before I move
Okay.
to the next one.
Because we got 2 more issues.
What issue is that?
Huh?
1 and 2?
I mean, the next problem is what happens wherever you have something with an x squared in it. Wherever you factor and one of your factors has an x squared in it. It doesn't work right. You have to change what you do. I did it this way because last time there were questions about, well, why is that minus sign? So I did it this way just to show the other way you could do it. All right, we good? Can I switch? Oh my God. The time is just wasting away. I can see the seconds ticking by.
Wait, any hour?
Oh my God, 23 minutes now. Okay. Okay, so I go to factor this one. Okay, x squared plus 4 does not factor any farther. Okay, whenever you have a power in the denominator, it changes what you do in the numerator. So this one is still A, but now this one is that. I get it because I made it up. I told you it. Because I want it. Oh, here, let me mess with you even more. Well, what if I don't want to do it that way? What if I decide to do it this way? How does that change things? Oh my God, that makes it this. Is that okay to do it that way? Yeah, because you're making up the variables randomly. Who cares? That means my A might be different from whoever put the x first. It doesn't matter because in the end, your fractions will be the exact same, just in a different order.
Need an X plus B?
Yes, it has to have an x plus b. Whenever you do your variables, your numerator can have up to 1 power less. So if I have an x to the 5th in the denominator, my numerator can have anything up to an x to the 4th. It may not need it. If it doesn't need it, guess what? A would be 0.
Why do you add? Why is it not just 8x?
Why is it B that at all? Like, why
Okay, if b is not needed, it will end up being 0. But you have to plan for every possibility.
so, I mean, like, one person why is like that one fraction rather than its own fraction? How do we know?
Is it a square on it?
You don't.
Or is it on?
What do you mean on its own fraction? Why Why do you not do AX?
Normally there's like A and then there's no B on it, and then C. Like, where'd you get like the X plus anything? Where'd that come from?
Because it's its own polynomial. Whenever, okay,
You did math, like, you didn't do math.
whenever, we haven't done any math yet. Whenever you have a power in the denominator, you can have a polynomial in the numerator that's one power less. The degree is one less.
When you say can, you mean less?
No, can, because if it doesn't, if it's not supposed to be there, then A will be 0.
Wait, did you,
We don't know what's supposed to be there. We're guessing. And then the math will work out to be whatever it's supposed to be.
I just don't see where there's an X something. The degree under.
Yeah, you plan for every possibility, then the math will tell you what's supposed to be there. Yeah.
Okay, so if it's supposed, if it can, like, one less, then the last one you do for the X plus 1 degree.
No, because your power for your actual, you do the power on the actual X. I know that gets a little confusing with that, but you do the power on X. I know, but that's why we always use the factored form. I know, you use the factored form and you do the power on the power.
The theory is before, I just, why do I put that? I don't understand it.
Trust me, if you did it, you could try it. If you put the AX on top of that, the A would always end up being 0. I mean, there would be no harm in doing it. You could do it, but you would always end up getting A.
Wait, who did all of
So,
How many, like,
so it would be a waste of your time.
So, you know how like the other ones had like A, B, and C? Where did that,
one of those, like,
where is that? How do I, where did you
One of those guys.
Okay. No. All right. Wait. Okay. First of all, stop. Way too much talking. Half the talking doesn't have anything to do with this. Okay. I'm trying to show you guys the rules. So far, we haven't got to this rule because we didn't have anything this complicated in the denominator. I'm not going to go through all the math to show you where all these rules come from because already just going through these rules is taking us way too long. I mean, we could spend 3 or 4 days with me showing you proofs for all these rules. Okay, first, one of the questions was, on the last one, we had a square in the denominator. Okay, why on that one did we not put an X above on that one? You could. If you did, it would always end up being 0. Again, there is a proof for that. I'm not going to spend the time showing you the proof, but if you did, it would always end up being 0. It wouldn't hurt you to do that. It would just give you an extra variable whenever you're going and doing your math down below.
wait, so I could do this just A, B, and C?
On this one, no.
Here, Josh, look. This one, right here, it's on X, right here.
So what I'm saying is, on this last one, with this squared, you could put an X up here as well. It would be a waste of your time. There are proofs showing that it would be a waste of your time. I'm not going to go through those. What we care about is whatever is on the actual X. This squared's not on the X, so it doesn't matter. Whatever power is on the X, you want to start with one power less in your numerator and count down. Okay? Okay. Just go ahead.
Why didn't you put B plus C in the second one?
On which one? This one? This one. Example 2? On this one, right here. To the left, this one. Okay, there's only an x. There's no power there. Okay, you want the power in the numerator to be 1 less than the power in the denominator. Okay, so since there's no power in the denominator, I don't need a power in the numerator. Okay, here I have a power in the denominator, so I have to have 1 less power in the numerator. So since I have an x squared, I need an x to the 1. If this was an x to the 5th, I would need an x to the 4th. So up here I'd have x to the 4th, x cubed, x squared, x, and then a constant. Yeah.
You need all of them?
Yes, you would need all of them.
If it's x to the fifth, you need one with x to the fifth, x to the fourth, one with x fourth, x to the third,
Yes.
x to the third, x to the second.
Yes. Okay, no, I don't. If this was x to the 4th, I wouldn't need another fraction with